Alright guys, today we are going to be solving systems of linear equations by graphing. So system means you have two equations, right? So imagine if you have like a y is equal to 2x plus 3. Okay, that means that there are many x's and y's that will work, right? If I put 1 in for x, what would y have to be? Y would have to be 5, right? So this is a solution. If I put 2 in for x, I get 7. If I put 3 in for x, I get 9. So there are so many different solutions for this equation here. Okay, there are many solutions. Now, if you are doing a system, however, like y is equal to 4x minus 2, okay, that means that this guy will have different sets of solutions, right? A different set. So you have x and y, and then you put 1 in for x, you get 2. You put 2 in for x, you get 6. Things like that. So when you're solving a system of two of them, you're looking for the solution that works for both. Okay, you're looking for one that works for both. So the really easier way to do this is to graph both lines. So you have like a bunch of points here. So I have this top one, right? 1, 5, 2, 7. And it goes like this, I guess. It goes like that. And then this other one, 1, 2, 2, 6. Yeah, so uh, that line has all those points. So you're just looking for the point that they intersect, right? The point that they intersect is the solution. Somewhere up here, they intersect. And that is the solution that they both share. That is the point that they both share. Okay, so that's the idea of that. If you have a system of two equations, you graph them, the point of intersection is your solution. Okay, um, what happens if you have two lines that don't intersect ever, like they just parallel? Then that means no solution, right? Or if you have two lines that are exactly the same, like on top of each other, two lines that go on top of each other, then what are the solutions? That means there are infinitely many solutions. Okay, so I have that here for you guys. I do suggest uh, that you write this down. Take notes, write it down. So you see if they intersect, there is one solution, and you find that point. What is that point? Okay, that's the solution. If they are just the same line on top of each other, that means infinitely many solutions. All those points are solutions. If they are parallel, then they don't intersect. So there is no solution. Okay, so let's do a couple examples here. I have example number 1. I have y is equal to negative 4x plus 8. And I have 2x. This is the other equation, right? 2x minus 3y is equal to 18. I'm going to graph the first one. The first one looks like it's easy to graph, right? I start at 8. So that's 8. That's 0. Oh, that's 7. So I guess 8 should be here. And then go down 4 over 1. Down 4 over 1. Down 4 over 1. Okay, that's my graph. All right, I'm going to make this a different color. So I want to do this one. Well, this one I can't really graph it until I switch this into slope-intercept form. So I'm going to subtract 2x. So negative 3y is equal to negative 2x plus 18. And then I divide it by negative 3. Y is equal to 2/3 x minus 6. Okay, so you start at negative 6 and go up 2 over 3. Up 2 over 3. Okay, so you see right away they intersect at that point. Okay, so the point of intersection is right here. That means that is the solution. Okay, so your solution is x is equal to, let's see, x is 3. Y is negative 4. And sometimes you can write it in a different way, right? Like positive 3 and negative 4. something like that. Depends on which way they want you to write your solution, but x is 3, y is negative 4. You can write it as a point, okay, because they intersect there. All right, so basically you just have to graph them and find the point of intersection. Okay. Let's do another example here. I have 2x plus y is equal to 4, and 2x plus y is equal to 1. All right, let's graph them. This one becomes y is equal to negative 2x plus 4. And let me graph this one first. So start at 4 and go down 2 over 1, down 2 over 1, down 2 over 1. All right, and that's my first one. Okay, the second one, make it a different color. So here I have y is equal to negative 2x plus 1. So you start at 1, but you also go down 2 over 1, down 2 over 1, down 2 over 1. So you can see that they will never intersect, right? Because they have the same slope. Same slope. They don't intersect because they start at different points. So this one is no solution. Let's do one more example. I have 4x minus 3y is equal to 6. And then 8x minus 6y is equal to 12. So let's graph this by changing it to slope-intercept form. I have negative 3y is equal to negative 4x plus 6, and then divided by negative 3. Y is equal to 4/3 x minus 2. Okay. And then I'm going to do this equation. Subtract 8x. Negative 6y is equal to negative 8x plus 12. And then divided by negative 6. Y is equal to 4/3 x minus 2. Okay, so I'm going to graph this. I have negative 2 starting at negative 2 and then go up 4 over 3. Up 4 over 3. Okay, down 4 to the other side 3. All right, now if I graph the red one, I start at negative 2 and I do the same thing because it's the same equation. Up 4 over 3, up 4 over 3. So you guys see that it's the same line, right? It's the same line. That means that they have infinitely many solutions. Okay?